Algebra 2 students, we're just about done with our quadratic unit. At this point, you should be able to solve any quadratic equation. Remember, no matter what the equation is, as long as it has an equal sign, you should be able to make it look like ax squared plus bx plus c equals 0. And if you can make it look like this, you have three ways to solve, technically two. You can factor to solve, which is what I always recommend. If it's possible, factor to solve. Then the second way, or the second method, is complete the square, and that's really all there is. But the third method is the quadratic formula. Remember, the quadratic formula is just completing the square using the symbols ax, a, b, and c in this general quadratic equation, and completing the square using only symbols as opposed to numbers. So, those are your two methods, factor and completing the square. I will test you on all three. Can you factor? Can you complete the square? And do you know the quadratic formula? And can you use that? Remember, the quadratic formula does allow you to check for things like the types of solutions, or things like that. B squared minus 4ac, that discriminant. The other thing that you should be able to do is you should be able to graph any quadratic equation that's in general form. That's what we talked about yesterday, or that's in vertex form. And there's a couple ways to get to vertex form. You can complete the square on this and work on one side of the equation, and that'll get to vertex form. The other thing you can do is use the methods with the general form to find negative b over 2a, plug that in, find the y-coordinate of the vertex, you know that's k, and then you just rewrite it. Today we're going to do one more extra type of graphing with a quadratic. It's not that complicated, and it only works with some quadratics. It doesn't work with all quadratics. And it's called intercept form. And it looks like this. Y equals a, x minus p times x minus q. The reason it doesn't work for every quadratic is it only works for quadratics that have x-intercepts. So if you look at a quadratic and it does this, this graph will never cross the x-axis, so there is no intercept form. And intercept form is a lot like factoring a general quadratic. So let's try a simple one. If I tell you graph the following quadratic, and I say y is equal to x squared plus 6x plus 5. Well, another way to write this is x plus 5 times x plus 1. That means negative 5 and negative 1 are the x-intercepts. And if I graph the x-intercepts of negative 5 and negative 1, what I know is halfway between those values at negative 3, I have the axis of symmetry. I know it's the axis of symmetry because those 2 points are aligned horizontally, and all points on a parabola have that symmetry. So now what I could do is I could plug in that value of negative 3 into my original equation, get negative 3 quantity squared plus 6 times negative 3 plus 5. That ends up giving me 9 minus 18 plus 5. That ends up giving me negative 5. So now I know the vertex. Now the a value here is 1. So I could go from the vertex over 1, up 1, over 2, up 1, 2, 3, 4. Ooh, I must have made a mistake. Where is my mistake? Do you guys see it? Negative 9. Oh, negative 4. You guys are probably sitting there saying, Stubbs, check your math. That should be a negative 4. All right, so that's the vertex. So over 1, up 1, over 2, up 1, 2, 3, 4. Okay, now it's working. So I'm not going to erase this video and re-record it because I want you to see that I make mistakes. but I also want you to see how I can tell when I made a mistake and then what I end up doing once I make the mistake. I start to go back and I look at my work, and this is why I always encourage you to write your work out so you can find your mistake. I made the mistake of thinking 9 plus 5 was 13 and not 14, and then 14 plus negative 18 is negative 4. Anyway, notice how that A value, being a 1, still shows from the vertex. Over 1 up 1, over 2 up 4, over 3 up 9, over 10 up 100, right? Back 10 up 100, back 7 up 49, back 6 up 36, right? It's just dealing with y equals x squared once you're moving from the vertex. Good? Let's try another example. What if I told you... what if I told you you had a quadratic where the x-intercepts were at -2 and +4, and the vertex was the point, well, not the vertex, let's just say it went through the point. That'll be more fun. Let's say it goes through the point, I don't know, 1, 10. So this may not be nice because I'm just making it up. All right, so we know the x-intercepts. So we know we can write this graph y equals a times x plus 2 times x minus 4. Notice what happens there. The x-intercept is -2, so the factor is x plus 2. The x-intercept is +4, so the factor is x minus 4. If you plug in a 4, this becomes a 0. If you plug in a -2, this becomes a 0. Now the next thing I do is I plug in this value of x and this value of y, and I get 10 equals a times 3 times -3. Good? Oh man, I messed up. That is the vertex, so still not that hard. So now I get 3 times -3 is -9. I get 10 equals -9a. And so I get a equals 10 over -9. So not the greatest a value, but what that means is I could just write the function -10 over 9 times x plus 2 times x minus 4. And that would be your function. Good? So a couple different ways of graphing quadratics. So again, in summary, all the stuff we've been working on so far this unit, you should be able to graph any kind of quadratic, y equals ax squared plus bx plus c, and be able to express it into vertex form, and if applicable, express it in intercept form, which is y equals a times x minus p times x minus q. The a value in all three of those quadratic functions is the same. The other thing you should be able to do is replace y with some number, and you should be able to solve any quadratic equation. Ax squared plus bx plus c equals 0. Because remember, you can always collect the like terms and get a quadratic equation set equal to 0. Good? 2 ways to solve factoring and completing the square. Know the quadratic formula, know about simplifying radicals and irrational numbers, know about conjugates, and that's pretty much this unit. All right, have a good one, guys. Peace.